This is the third video on section 6.3, the chain rule. And for this example, what we're going to do is we have z expressed as a function of x and y. X and y are both functions of two variables themselves. And so what we're going to do is we're going to calculate the partial derivative of z with respect to s and the partial derivative of z with respect to t using the chain rule. And so first of all, we have some partial derivatives to calculate. We calculate the partial derivative of z with respect to x, the partial derivative of z with respect to y. We also calculate the partial derivative of x with respect to s, the partial derivative of x with respect to t, the partial derivative of y with respect to s, and the partial derivative of y with respect to t. And so we're going to use the chain rule, and the procedure is very similar to if x and y were simply functions of one variable, like the last two examples. So, the partial derivative of z with respect to s is a partial derivative of z with respect to x times a partial derivative of x with respect to s plus partial derivative of z with respect to y times the partial derivative of y with respect to s. Notice something. We're taking the partial derivative of z with respect to s, so when we multiply, we're multiplying the partial derivatives with respect to s. The partial derivative with respect to t is not used here at all, because we're calculating partial derivatives with respect to s. We substitute these terms here. We calculated these on this board. So we already know what these partial derivatives are, so we substitute those terms right there. And we know that x is st plus 2, so we substitute st plus 2 in for x. And we know that y is s squared plus t, so we substitute s squared plus t in for y. After we do that, we simply have the partial derivative of z with respect to s, and this has only s and t variables in it. Then we calculate the partial derivative of z with respect to t. We have the partial derivative of z with respect to x times the partial derivative of x with respect to t plus the partial derivative of z with respect to y times the partial derivative of y with respect to t. Notice the partial derivative of s is not part of this. We used it up here, but we're not going to use it down here because we're calculating the partial derivative of z with respect to t. So these four terms here that we're using, we've already calculated those on this board here. So we know what the partial derivative of z with respect to x is, partial derivative of x with respect to t, partial derivative of z with respect to y, and the partial derivative of y with respect to t. And so we substitute. Okay, and so this is what we have. And now on the next step, we substitute. X is st plus 2, y is s squared plus t, so we substitute those values for x and y respectively, and then we have terms in terms of only s and t.